Right, so this is the homework from the second. Yeah, it's our last class was the second. Yeah. Sorry, I keep forgetting. So we have class Monday, Tuesday, Wednesday. So I should have homework from everyone for the 24th, the 25th, and the 2nd. They're the classes that I taught you on the 24th and I gave you homework. The 25th was the first class online, and then the 2nd then as well. Right, so anyway, I'll check if this is done before I post it, but these are the solutions. So a body is projected vertically upward from the ground with an initial velocity of 200 meters per second. Find the greatest height reached and the time taken. Okay, so question 2. I'm just going to bring these lines a bit closer together. We'll go UVAST. Initial velocity, it says, is 200 meters per second is the correct unit. It does have greatest height, and we know at the greatest height, the final velocity is 0. It's going upward, which means our acceleration is minus 9.8 meters per second. Find the greatest height, so we want to know this, and the time it takes, so we also want to know this. Right. I might find the time first, I think, because I can do V equals U plus AT, 0 equals 200 plus minus 9.8 times T. So 0 equals 200, plus by minus is a minus 9.8 T. If I do plus 9.8 T to cancel that out, and plus 9.8 T on the other, yep. Sorry, plus 9.8 T on the other side. That gives me 9.8 T equals 200, and I would like to isolate the T. So I'll divide by 9.8, divide by 9.8. So T equals 20.41. That's rounded to 2 decimal places. Okay, so that's 20.41. I am actually going to hold all the decimal places. So we'll go purple for this one. So now that I have that, I can use S equals UT plus a half AT squared. So U is 200, T is 20.41, or the full version of that number. A half, acceleration is minus 9.8, and this is 20.41 squared. Okay, so that number, I might store that. Okay. So that times 200. Plus a half bracket minus 9.8 bracket that number squared. So I'm getting 2040.82 meters. Okay, so hopefully that's right. You can obviously let me know if it's not. And it doesn't really matter which way you go about that. Whichever way you go about it, you should get the right answer. And we should all agree on our answers, I suppose, is a better way to say it. A stone is projected vertically upwards from the ground and reaches a height of 100 meters in 2 seconds. Find its initial velocity, the greatest height reach, and after how long, after being at a height of 100 meters, is it again? Okay. Right. Do the first one first. All right, it says, the part 1 says find the initial velocity, so we don't know that. It's projected vertically upwards. Don't know V. It's going upwards, so we know that this is minus 9.8. It reaches a height of 100 meters, so we know that. and it says it takes 2 seconds. Right. Do this one in red. Is it ut plus a half at squared? I was just going through the different ones. There's not many we can use, not having u or v. So s is 100. U we don't know. T is 2. A half minus 9.8, 2 squared. So 100 equals 2u. Now this I can figure out. So a half bracket minus 9.8 bracket 2 squared is minus 19.6. I'm going to plus 19.6 here and plus 19.6 on this side. So that gives me 119.6 equals 2u. And then I want that, so I'm going to divide by 2. Divide by 2. So 59.8 is the initial velocity. It's a velocity, so meters per second. So that's here. Okay, find the greatest height reached. Okay, so I actually need to do a new UVAST here. So UVAST. So we know that U is now 59.8 because we figured it out. The greatest height will give us V equals 0. Acceleration stays as minus 9.8. We want the greatest height, so we don't know this anymore. And the 2 seconds was associated with the 100 meters, so we don't know T either, but I don't think we want to know it. Don't think so. Right, so we're looking for S. So can we go oh, we can't. Sorry, I was going to do S equals ut plus a half at squared, but I don't have T. V squared, that one. So V squared equals U squared plus 2AS. 0 squared equals 59.8 squared plus 2 by minus 9.8 by S. This is 0. This is 3576.04. This is minus 19.6 S. Okay, so if I plus 19.6 S, I'll get rid of that. But if I do that on the right, I have to do it on the left. 0 plus 19.6 S is just 19.6 S. And that equals 3576.04. Divided by 19.6 to isolate the S, divided by 19.6. So S equals 3576.04 divided by 19.6 is 182.45 meters. Okay. Now part 3, I don't know if any of you actually figured this one out. So how long, okay, I need a picture. Okay. So it's on the ground. Here's the ground. It's being projected vertically upwards. It reaches 100 meters after 2 seconds. It then, we now know, continues up until it reaches its greatest height, which is 182.45. It then comes back down. So we want to know basically this time and this time. So how long does it take to get from 100 to 182.45, and then how long does it take to get from 182.45 to 100, which should be the same, shouldn't it? Okay, I'll just do these in two different colours. Do red and green. Okay, so you've asked for the red. Okay, so that's kind of from here. So do we know the initial velocity there? Did we figure that out? No. So this, the 59.8 is the initial velocity from the ground. Now we could probably figure it out because we have a lot of information. Like if we took here v equals u plus at, v equals 59.8 plus minus 9.8 times 2. So that is 59.8 plus minus 9.8 bracket 2. So that's 40.2. So that means when it gets to the red dot, it has a velocity of 40.2. So that's the initial velocity for the red bit of the journey. Yeah? So that's 40.2. Oh, I think I could probably figure this out a different way. Anyway, the final velocity is 0. This is minus 9.8. Oh, we possibly didn't even need it because we can figure out the distance. The distance is 82.45 and we just need to figure out the time. So I'd say we could have done that. Sorry, my dinner was burning. We probably could have done it without the U. Let's try and do it. So I'm going to pretend I don't have that. Oh no, maybe I can't. V equals u plus at. No. Not without u. V squared is u squared plus 2as. No. S equals ut plus half at squared. No. No, I did need it. It was not a waste of time. Okay, so let's go with v equals u plus at. V is 0, u is 40.2, a is minus 9.8, and t is t. 0 is 40.2 minus 9.8t. Same maths we've done a few times now. So plus 9.8t to cancel, plus 9.8t over here to balance. So that is 9.8t equals 40.2. Sorry, I want to isolate the t, so I'm going to divide by 9.8. Divide by 9.8. So t is 4.102. I'm wondering now, could I have used this to get the time for the whole journey? I'm going to try this too, sorry. V equals u plus at, so 0 equals 59.8 plus minus 9.8 times t. So 59.8 minus 9.8t. And that gives me plus 9.8t to cancel and plus 9.8t. So 9.8t equals 59.8 and then divide. Divide by 9.8, divide by 9.8. So t is, yeah, 6.102. So that's another way. Sorry, I've just figured it out twice, essentially. What I'm after figuring out there is that to get from the bottom to the top is 6.102 seconds. And we know this bottom part is 2 seconds. So that means the top part is 4.102 seconds, which is what I had figured out over here anyway. Sorry, I was just curious. Yeah? Okay, so then I think, given the acceleration is the same, just in the opposite direction, I mean, I'll do the maths, but I think it's going to be the same to get the green t. So you've asked for the green t. The initial velocity is 0 at the top. The final velocity we don't know. Hopefully that's not a problem. The acceleration is 9.8 because it's falling down now. The distance is still 82.45 and the time is still what we want to know. So can I do that? Oh God, like, okay. I can use s equals ut plus a half at squared directly, but it's going to have a t squared, and let's not play that game. So I think if we figure out v, it's going to make it easier. So v equals u plus at, v equals 0 plus a is 9.8 t. No, I can't figure out v that way. Okay, we'll do it this way. V squared is u squared plus 2as. So that is v squared is 0 squared plus 2 by 9.8 by 82.45. So v squared is, typing into my calculator, 1616.02, and then if I square root both sides, I get 40.2. Yeah, so it's going to work out the same. 40.2 was my initial velocity over here, and it's my final velocity over here, which is what I suspected, that it was going to be like symmetrical. So v equals u plus at. Now I can use this because I have 40.2 equals 0 plus 9.8 times t. 40.2 equals 9.8 t. Isolate the t, divide by the 9.8, divide by 9.8, and we get 4. So the question was, how long after being at a height of 100 meters above the ground is it again 100 meters above the ground? And what we have figured out is that the total time is 4.102 twice. So it's 8.204 seconds. All right, and then question 7. So from a point 16 meters above the ground, a ball is thrown vertically upwards with an initial velocity. Okay, sorry, need a picture. So 16 meters above the ground, a ball is thrown vertically upwards with an initial velocity of 24. Find the greatest height. Okay, so U, V, A, S, T. U we were given 24. Greatest height means velocity is 0. It's gone up, so minus 9.8. This is what we want. Okay, so for part 1, we need S, and we don't have T. So V squared equals U squared plus 2AS. So V squared is 0 squared. 24 squared plus 2 by minus 9.8 by S. So 24 squared is 576. 2 by minus 9.8. Oh, 2 by minus 9.8 is minus 19.6. Okay. So plus 19.6s to cancel and plus 19.6s to balance. You can see the maths is very similar. So the maths is not the hard part, the problems are the hard part, as I've said before. So we divide by 19.6 to isolate the s and divide by 19.6 on this side. So that is 29.39. Now that's going to be 29.39 like up here, but that's obviously I I think you probably have to add the 16 on, do you know what I mean? So get the overall greatest height. So it's 29.39 above the 16 meter platform that it started on. So 45.39 meters is the overall greatest height. The total time it takes to reach the ground. Okay, so we can figure out this time here, and that will give us the time from here to the top. Okay, so let's do this. So time from 16 to top. Okay, I'm using the UVAS that's already there, so can I do V equals U plus AT? I think I can. Yeah, because I need T. So V equals U plus AT. V is 0, greatest height, started at 24. Acceleration, it's going up, so minus 9.8, and time we don't know. Same again. Okay. Plus the 9.8t to cancel, plus the 9.8t on this side. So then 9.8t equals 24. And then divide by 9.8, divide by 9.8 to isolate the t. And we get 24 divided by 9.8 is 2.45 seconds. Okay. And then if we do the time from the top to the ground. Now I think we need a new UVAST here, right? So UVAST. So it's going to start at 0 because at the greatest height it was at 0. We're not going to know the velocity. The velocity, I know, obviously, ultimately it will hit the ground and stop, but we're looking for the final velocity is the kind of max speed it has right before it hits the ground. So it's not really a question mark because I don't think we care. It's falling down, which is 9.8 meters per second. We know that that distance is 45.39 because it was the height we calculated plus the 16. And then the time is what we're trying to figure out. So is this exactly what we had over here? Yeah. So I think we can do it with S equals UT plus a half AT squared, but then we'll have our variable squared, which means we're solving a quadratic, and nobody wants to do that. So let's find V. So, I did it again. Sorry. We find V using V squared equals U squared plus 2AS. So V squared equals 0 squared plus 2 by 9.8 by 45.39. So V squared is 889. So then square root to get 29.83. So that's this one, 29.83. And now I can use V equals U plus AT to get the time. So 29.83 equals 0 plus 9.8 times T. So 29.83 equals 9.8T. And then we're going to divide by 9.8, divide by 9.8. So T is 29.83 divided by 9.8 is 3.04 seconds. So the question was, what's the total time it takes to reach the ground? So it takes this long to get from 16 meters to the top. It takes this long to get from the top to the ground. So then our total time is 2.45 plus 3.04 is 5.49 seconds in total. Oh, the velocity with which it strikes the ground. We figured that out. It's there. Meters per second. 29.83 will be the max velocity right before it strikes the ground. All right, so those, especially those time ones that we did, like the very last one there, or not the last one, the second last one there, part 2, and then the one over here where we calculate the time. Now they're the same question, but they're tricky. All right, so obviously I just went through that at whatever pace suited me, because you have the beauty of being able to pause it and go back over it, rewind it if you need extra help. And obviously, if even after hearing me do the solutions and seeing me do the solutions and pausing and rewinding, you still haven't a clue, you have to ask me. Okay, so if there's something that you still need answered, please let me know. All right. Thanks, guys.